Click. Hi, I'm Carolyn, and I'm going to show you my concept map. I know in the instructions it said to have somebody else videotape for you, but honestly, this would just be way easier for me. And the way you can tell that it's me, besides my voice and the way this is just a one-shot video is, see, I have this ring on my right hand, which you'll see moving about the thing when I give my presentation. And anyways, so let's begin. Crap. This thing doesn't rotate the other way. Okay, never mind, starting over. Hi, I'm Carolyn, and I'm gonna show you my concept map. I'm about to flip the camera over so you guys can see it. Not very artistic or anything, so yeah, just go with me, I'll explain it as I go. And I am left-handed, which means that my ink tends to smear the more that I write. So if it's blurry, I apologize, but yeah, really quickly. So first, here in the center, we're gonna, I decided to title this Basic Terms to Know. So just basic things you need to know for cell biology. So first up, our subcategory number 1 is basic chemistry. And chemistry basically starts with elements, which are made up of atoms. The atomic theory, well, the modern atomic theory, was proposed by Professor Dalton. He also made the law of partial pressures. Atoms are made of, that's what MO stands for, see? I just abbreviated because it would take too long. Protons, neutrons, and electrons. Electrons form the electron shell. Neutrons form the nucleus, along with protons. Protons also form the nucleus. Neutrons and protons determine the atomic weight, which will then determine the molecular weight of a substance, which will then determine how many moles of a substance you have. Your moles will determine your molarity, which is the number of moles per liter of a solution that something has. And moles comes from Avogadro's number, which is the number of molecules of a substance in a mole, otherwise known as 6.022 times 10 to the 23rd. And over here, really quickly, protons determine your atomic number. That's what determines your atomic number. Excellent. So, moving over, our subcategory number 2 is bonds and complex chemistry. So, your basic types of bonds, you have ionic bonds, hydrophobic interactions, which I know isn't technically a type of bond, but I mean just fit as a subcategory, and covalent bonds. Alright, so starting over here with ionic, ionic bonds are what make redox reactions, which include an acid and a base. And an acid and a base put together makes a neutral substance known as a salt. Alright, so let's start with acids. Acids donate hydrogen ions, and so acids become anions. Anions help measure the pH, which is actually the measure of hydrogen atoms in a substance, and are universally called an electron acceptor. Alright? And then over here we have a base. A base accepts hydrogen ions, thus becoming a hydronium, which then becomes a cat, which is called a cation because it's positive, and is universally known as an electron donor. Alright, with me so far? Excellent. So up here we have hydrophobic, and when I think of hydrophobic, I think of water, which is a pure substance known as the universal solvent, which also has isotopes, which can be radioactive. And if they're radioactive, it means they decompose kind of spontaneously, thus giving us half-lives, which tell us the amount of time it takes a radioactive isotope to lose half of its original substance. Moving over here, water also has hydrogen bonding, which gives you the hydrogen bond network of water, which results in isomers because it allows for the redistribution of electrons and such things, and different like bonding angles and such. and it helps explain cohesion and adhesion. The way water droplets stick together is cohesion, and the way water droplets like stick to your finger or the window pane is called adhesion. Got it? Excellent. Alright, so now we're going to move up here, follow me. These are elements that are critical to life. Notice, if you will, these all center around basic terms you need to know for cell biology. So these are elements critical to life, should specify life on Earth. We have no idea if, civilizations in other galaxies, maybe they need other elements to live off of. Anywho, so we have oxygen, carbon, nitrogen, sulfur, hydrogen, phosphorus, potassium, sodium, chlorine, and lastly, calcium. So these are all elements that are critical to life. Now from these critical to life elements, we have functional groups, which is a lot of the focus of organic chemistry. And if you have to take organic chemistry, I am extremely sorry. So let's just get right into it. These are the different types of functional groups. Well, the basic types, you have hydroxyl, carbonyl, ketone, aldehyde, an amino, a methyl, and a phosphate. I abbreviated phosphate because I ran out of room. Hydroxyls form alcohols, and if you have an hydroxyl with a carbonyl, you get a carboxyl, and carboxyls form carboxylic acids. And then over here, if you see under amino, I have aminos can help form amines, which have radicals just like the sulfhydryl. That's how I link those two together. That's how I associate them. And all of these things are studied in organic chemistry, which is the study of carbon-based atoms as opposed to, that's what that connection says there, inorganic chemistry, which is the study of compounds and such that don't have carbon. Alright? Cool. Awesome. Moving on, 2 more to go. So from functional groups, you can also make polymers and monomers. Again, notice connected to my basic terms to know for cell biology. Alright, so polymers and monomers. So your basic building blocks are, of course, your monomers, which are amino acids. Sugar is technically not a monomer, but just go with me, I'll explain. And lipids. Okay, so let's start over here with amino acids. Amino acids form proteins, which later help to form glycoproteins. Alright? Sugars are included in monosaccharides, meaning single sugar, and monosaccharides then link together to form a polysaccharide. Awesome? Good. Alright, sugars then come over here and help form nucleotide, which I know is technically a monomer, but I mean sugars are included in a nucleotide. And from a nucleotide, you can get a nucleic acid. And then over here we have lipids, or fats. So fats have 2 categories. You have unsaturated, meaning not bonded, or then you have bonded fats, called saturated fat. Saturated fat means that everything that could bond with it, like all the spaces are taken up. And from a saturated fat, you can kind of compose a fatty acid. I don't know, it's just easy for me to put all the fats together. And then I moved over here to glycerol. Because if you have a fat and glycerol, you can form a glycolipid, which is just a lipid with glycerol. And when I think of glycolipids, I also think of phospholipids. So that's just how I link that together. I'm sorry there's no label, but I didn't really know what to put there. And again, I know that I could link glycolipid to, or glycoprotein over here to glycolipid, but honestly there's a billion connections to this, and I just didn't have the energy to try and make the like 10 to the 64th different combinations of this. So I hope this is just, I don't know, just, I hope you get it, basically. Anyways, last one, moving on, this one is easy. So these are just your basic units of measurement that you use in science. It says subcategory 2 over here because originally I was going to start with this like as my branch off, but I just decided to end with it because it's quick. So your basic units of measurement for length, mass, and volume. For length you have a meter, for mass you have a gram, and for volume you have a liter, not meter. And liters are made up of milliliters, which is basically 1 over 1,000 of a liter. So it's 1/1000th of a liter. Anyways, that's it. See, this is my ring that you'll see in all the videos. I'll put it on my pointer finger next time. And yeah. So I'm Carolyn, and or I'll turn the camera this way. I'm Carolyn. Hopefully, like, that wasn't just whatever. I'll get better at this, I promise. Please be gentle with the grading. Artistic things are just, it's not my thing. Bye, and see you.